So Simon has recently retired after a career in respiratory protection research for over 35 years. This started with doctoral work on sorbent media, followed by employment with respirator manufacturers. First, Racal Health and Safety as a research manager, and after its takeover by 3M, a continuation as a research scientist in Brockville, Ontario. He worked in filter development and evaluation methods for new products for military, industry, healthcare, and emergency responder applications. Simon has been contributing to standards development for about 15 years and is currently chair of an ISO working group creating international standards for respirators for emergency responders, and he also chairs the Canadian Standards Bioaerosol Working Group, which has a fabulous process for choosing a respirator for bioaerosols. Very applicable in this time of the pandemic. Simon has formerly served as president of the International Society for Respiratory Protection and chair of the American Industrial Hygiene Association Respiratory Protection Committee. And what we're finding collectively, Simon's the go-to guy. If anybody has a tricky question about respiratory protection, we go to Simon. So once again, Dr. Smith, we're really grateful for you to present. So over to you, Dr. Smith.
Thank you very much. I hope everyone can hear me. Thanks for your kind words and for the invitation today. It's great to have such an interest and such a large audience to speak to. The subject of the presentation is on personal protective equipment, but I am going to touch on that as a whole subject briefly, but then really focus on respiratory protection, as that is, I guess, the area in which there's most focus at the moment. Recognizing the hierarchy of controls, personal protective equipment is at the lower end of that. It's the last resort and considered to be the least effective after all the other controls have been applied. Of course, with an infectious pandemic, there's not the chance to eliminate or even substitute, so it does count down to the engineering, administrative, and protective equipment controls. We'll mention, of course, definition is that it's equipment used to protect the individual from injury due to various kinds of workplace hazards, including biological hazards. And recognizing that there are needs for eye protection, for skin protection through gloves and through gowns, in some cases boots as well. But the main interest has been in various types of respiratory protection. And of course, as the hazards of the COVID disease have been recognized, there is the need not just for protection of workers and wearers of protection, but also the need for use of equipment for source control, which I'll touch on briefly as well. When it comes to respiratory protection, there's a lot of information out there, and it's convenient to summarize perhaps as the 3 Fs. And you may have heard of 2 Fs, filtration and fit, but adding another F to this, function, perhaps brings the whole thing together. At times you see publications from government and from other agencies focusing on the filtration of, as if that is synonymous with its overall protection. But you in fact need the other features. A device must fit well to the face, unless there's actually an air supply into it. So there's expelled air. You need to ensure that there is a close seal to the, so that the filter medium is actually effective and that air is not just going to bypass it. And the equipment must also allow the wearer of it to function. If it's too hard to breathe through, if it gets too hot, causes them to fatigue too fast, or they can't communicate and have to remove the product to speak, they're not getting protection for that period of time. And so the overall effectiveness is reduced. And therefore, not just filtration, but these 3 factors have to be combined into the design of a product to make it useful and provide effective protection. And on the screen at the bottom, you just see some of the terms you use. You hear about efficiency or penetration. You hear about fit testing and protection factor. I'll touch on those just briefly. And of course, when it comes to function, there are various features that may cause compromise in the function and then loss of protection. Just to mention the different kinds of equipment, you might say, product that are used and that are in fact different. We have become familiar now with what we might call barrier face coverings, the cloth masks that people are encouraged to wear in everyday outdoor activities. And a step up from that is a surgical mask. Workers in the healthcare field are familiar with those, and beyond that, approved respirators. The problem with barrier face coverings is that there is not necessarily effective for the face. There's no real guidance as to what they can be made from, and no performance requirements. Actually, there are some standards under development, but it is pretty much a free-for-all. Surgical masks do not seal well to the face, but they do have a filter medium that is on occasions tested and evaluated to certain standards, but not for all types. But the medium can be fluid resistant and prevent splash. Whereas for approved respirators, there is a good seal to the face when they're properly designed and selected and fitted. The filter material is tested according to standards and has to be quite highly effective. And there are other features to ensure a good fit and evaluation of fit when they're used. So you get a range of protection from the poorer side on the left there to the better side on the right. I've put some estimated star ratings to show the relative capability. So the ideal is the higher level in terms of a filtering respirator, filtering face piece, or other equipment. But we see for public use, the barrier face coverings, and for certain medical uses, surgical masks are offered. But because of the lack of seal, they do not provide adequate protection against aerosolized airborne contaminants. And so there are concerns at whether they are the right selection choice for general use in healthcare. One reason that filter media are different is indicated by the micrographs that are shown there. When you have a woven fabric, you tend to have larger gaps between the fibers compared with a non-woven that's generally used in high efficiency filters. Because of the random nature of the fibers in non-wovens, they tend to be a very effective barrier to passage of particles through the equipment itself. Again, with COVID, we've always thought of the filtering face piece as the sort of, they say, gold standard, the N95 class and so on. But in fact, there is a spectrum of capability of respiratory protective equipment that has been in use for many years, some in healthcare, many in industry. I will mention standards in a minute, but just to say, as far as performance standards go for these types of equipment, there has historically been no difference between those that are intended for use in industry and those that are intended for use in healthcare. There are certain extra points for healthcare, splash and flammability, but apart from that, what has been in use in North America and in other jurisdictions has been a common standard for all types of respirators, so that there's nothing particularly special about a healthcare respirator versus a non-healthcare one. And one issue around shortage, as has been pointed out frequently, is that there are many types of products available for use in industry that are perfectly adaptable for use in healthcare. What you see here is a sort of relative star rating and some numbers around the capabilities of different types of equipment. In general, what you see is for the higher level of protection, you pay a price both in money and in the burden and logistics and handling of the equipment. The highest level, self-contained breathing apparatus, doesn't really apply in healthcare, but it has a very limited duration of time. As you go to the right here, the level of protection goes down, but often the logistics and comfort factors go up. So we have really a matter that includes balancing the protection needed with other factors around selection. But it is point out that, as I say, face pieces frequently now, but there are other types suitable in healthcare. And when it comes to selection, where you need protection, say for use in medical procedures that may be conducted in poorly ventilated environments during an emergency, it may well be that a filtering facepiece is not the most adequate choice, and you may need to improve the level of protection to powered or full face respirators to achieve the acceptable level of capability. That's not widely recognized and not down to standards. Factors around ventilation and use of respirators. Just to mention information on filtering of particles, as Secretary Siegel mentioned, filters do not act like a tea strainer. It's not that they filter everything down to one size and let everything else through. As you see on the right here, the fibrous webs used in the efficient filters have multiple mechanisms for removing particles. And some of these are more effective for large particles and some more effective for smaller particles because you're relying on electric charge, which actually works strongly on a smaller particle. And so with this multiple mechanism process for removal of particles, the filtration efficiency, as was mentioned, does not cut off. These multiple processes actually combine so that you have this very small dip in efficiency, down from very close to 100%, at what is called the most penetrating particle size. And that's where filters are tested in their approval requirements and standards, and so that it is always known that when they are used in the workplaces, they will be more efficient than the value tested at that point. The 95 in an N95 designation actually represents 95% efficiency at this most penetrating size. When it comes to dealing with viruses, people say, well, the virus is a lot smaller than that, but the fact is that viruses are always attached to some larger particles, expelled fluids, dust, and so on, and in that case, those particles are of a larger size and are in the range where there is close to 100% filter efficiency. So an N95 product will be capable of removing the hazard posed by COVID and other pandemic illnesses. Where does N95 come from? Just to focus on that again, because we hear a lot about this. The historic situation, which is probably going to change shortly, is that in Canada, we have recognized a US approval system, and the National Institute for Occupational Safety and Health is a body that sets standards. It takes testing and issues approvals for respirators, and for use in the workplace against a hazard, products must be selected that meet the standard and have been approved by that agency. What's happening right now is that Canada is working on developing its own standard, mainly to try and the approval process and alleviate shortages. That you'll still be able to use the NIOSH products even when that system is in place. It covers all kinds of products from again, the self-contained breathing apparatus right to filtering face pieces. With the filtration structure, they brought this in 1995 when tuberculosis was in fact considered a hazard in and this matrix there of NRMP classifications and 95, 99, and 100 levels. N95 is for non-oil-based aerosols, and COVID conforms with that. The other two are for oil, and as mentioned in the box, oil can affect the efficiency of these electret media, where an electric charge has been dispersed on fibers in order to enhance the filter capability for small particles. Because oil can coat fibers, there are special classifications for the types of filters needed to deal with aerosols. Although they developed 9 types, in fact, over the 25 years since that standard came out, the market has merged so that we have some at the N95 end and others at the high. There's not much in between. You might see an N100 offered now and again, but generally now the choice is N95 or P100. And the P100 will certainly meet every requirement that an N95 does, but it has higher efficiency and ability to remove oil-based as well as non-oil aerosols. Should mention for the powered air types, there are some new classifications, the 100 NMP that came out recently. And those are capable, again, matching roughly the NMP definitions. The HE in the middle, which is the historic one, actually had to meet a very severe dust loading requirement, so meant that products were larger, heavier, and more limited in the way they could be used than they needed to be for healthcare needs. And so NIOSH actually last April brought out 2 new classifications, and there are some products now approved to those. Just mentioned, you might hear surgical masks with a clearance from the US Food and Drug Administration. This covers certain extra things. It has filter requirements in it, but they are not as stringent as required for respirators. But they do cover fluid resistance against a splash of liquid, say simulating a blood splash, flammability, but it's the same as general clothing flammability limits, and some are tested for biological filtration. But again, that is not as stringent as the respirator filtration tests. Going to the second F, fit. For workplace use, there's legislation in every province, territory in Canada, and that sets out requirements, refers to a Canadian standard that sets requirements for developing a respiratory protection program, so that workers who need to use respirators must be processed through a set of criteria, including a medical evaluation and a selection protocol, and then fit testing for an appropriate respirator to the task they are doing. Two ways that are undertaken for particle respirators is a qualitative fit test, where it relies on sensation of some material, a bitter or sweet aerosol, and a fit test where a measurement is actually made with a device that can sense dust in the air.
For you, yep. Simon.
Okay.
Oh, sorry, just a quick time check for you. Yeah.
How long have we got? Okay.
Oh, you're good. I just wanted to check in.
Right.
We want you to have questions. That's all.
Okay. Thanks. Sure. Yeah. Okay. On the fit test side, the quantitative and qualitative are undertaken when respirators are selected, whereas there's a user seal check to verify that the mask has been donned properly, that is undertaken every time it's used. Of source control and the dispersion of aerosol by different types of device. This is some work done actually around the time of H1N1, looking at dispersion from a wearer with nothing, or wearing a surgical type mask or a fitted respirator. This is on the left, and you can see that there is very good control of dispersion with the fitted respirator. We're now seeing questions about whether the public should use these, and this is sort of helping answer that sort of question. And again, you have on the right illustration, at the bottom illustration, showing the dispersion with a surgical mask and how the plume of material expelled moves away from the head. It's a question people talk about surgical sterile fields and problems with exhalation valves, but it's interesting that there may be criticism of valved respirators, but people are happy with surgical masks in that sense. Mentioned this table, which is interesting because this is a calculation not based on any value for infectious dose, because that is something that is still under discussion, but assuming that the 15 minutes of time to infection that CDC has identified as triggering the need for a contact trace can be extended by the use of barrier face coverings. On the left side, the type that the person expelling the material wears, right under inward leakage. At the respirator, the effectiveness of the equipment that the person receiving or inhaling and needing protection is wearing. And you see that with the lower level types of face covering, we're in the minutes range to get an infectious dose as a sort of relative guidance. You get the much better fitting of a well-fitting respirator up to just 1% leakage. The time to infectious dose goes up into the hours or hundreds of hours. So it shows the benefit here just in minimizing the chances of inhaling infectious material that having a well-fitting respirator gives. Room ventilation, again, this is based on poor ventilation, but room ventilation will actually extend that much further. Standard and certification, in the time I won't focus on these, just to say there are really two types, and you'll hear about NIOSH and such for the approval. And so there's approval according to standards for the design of the respirator, which ensure that it will work when it's been properly selected and fitted. It's a bit like for cars, making the car manufacturer put the seatbelt in properly, define where it's got to be clamped, what strength of force it must cope with, and so on. And there are systems around the world that address this. But as I mentioned, the same standards apply for healthcare as apply in general industry. Then there are selection and guidance standards. Selection guidance, so that there are standards that guide how you select the right kind of respirator and how you manage a respiratory protection program. And Canada has its own standard, CSA Z94.4, that covers this. And you can actually review this on a CSA website, and it has aspects that are appropriate to running a respiratory protection program, medical clearance, training, as well as the selection guidance according to a structured system. And as mentioned, it was the first one in the world to come up with a standard for biological aerosols. And that is, we hope, something that will get some more attention during this pandemic. People have been working on it for many years with operations in a pandemic in mind. I mentioned that IRSST, a research agency in Quebec, has followed on with that, so for their own guidance. Okay.
You have time for a question, Simon?
Pretty much the last slide, yes. Just to say, these are types of respirators that have aspects of use in healthcare. That's where you can grade down to alternatives from other approvals domains from NIOSH. You can upgrade to electromagnetic filtering phase pieces, and the Chinese KN95 types are a special category because although they normally meet filtration requirements, often the fit and the quality may not be consistent for North American use. So I'll stop there. Thanks.
Thank you so much.
Thank you very much, Dr. Smith. I just want to leave enough time for Alec to talk. There is one question here, and I think it's really important now. You know, for example, I went to Costco the other day and I ended up buying a KN95, and you can actually get a fix the mask that fits around the back of the head. So I just thought I'd preface it with that. But the question is actually from Maria Posamai. It says, Dr. Simon, does Dr. Smith have a perspective on jurisdictions like Germany, Austria, and Bavaria that have considered or implemented requirements making it compulsory for the public to wear high filtration masks on public transport and in shops?
Well, actually, one could go back to this table here and consider that the better the source control and the better the respirator worn, that the overall, in this case, longer time it's going to take to do an infectious dose. So yes, there is a benefit I would see to that in minimizing the expulsion of potentially infectious material from a wearer and protecting the wearer or the wearer of a mask for inhalation. The issue here is that a couple of things. One is that working workplaces a fit test program, as mentioned, but for public use there will probably not be a fit test program, but you're still going to get better protection wearing a certified type respirator than from a typical cloth barrier cover. So there's an improvement there. The other aspect, of course, is the fact that using such products for the general public may still exacerbate shortages in the healthcare community. Any of those products. There's a balance there, but for individual protection level, yes, it's an improvement, but of course there's that counterbalance too. Thanks.